Be watching here. Thank you. Okay. First up, guys, solving inequalities using addition and subtraction. Now, guys, we've been doing equations. But now we're going to do inequalities. So, Milan, what I'm talking about with inequalities is something that looks like this. Greater than, comma, less than, comma, greater than or equal to, comma, less than or equal to. Right? Guys, we know what those things are. We've seen them before. All right? So that's what we're going to be talking about. Now let me get them out of our way. Okay? The main point here is that we solve inequalities the exact same way that we solve equations. We undo subtraction by adding. We undo multiplication by dividing. We do it the same way. But there's only one exception, and it's in bold-faced letters, okay, up on our notes. The one exception says that you must flip the inequality sign whenever you multiply or divide by -1 on both sides of the equation. On both sides of the equation, you have to flip it. Okay? Will R, your question is? This is only going to occur when we change the signs. Okay, so it has to be multiplying by a negative on both sides or dividing by a negative on both sides. Adding and subtracting doesn't change a sign. Okay? Now, guys, you'll notice today, though, we're just doing addition and subtraction. So do you think that we're going to see this exception today, Taggart Bonham? No, we're not going to see that today. Okay? But we will see it tomorrow, so I wanted to bring it up today so we'll be prepared for it. Okay, guys. This says the freezing point of water is 0 degrees Celsius. At temperatures at or below the freezing point, water is a solid, also called ice. Okay? Write an inequality that gives the temperatures at which water is a solid. Then graph the inequality. And I want us to talk about this because we've got to graph things in a certain way. Hey guys, talk to me. What do I need to do, Henry? That's right, Henry. I need to write the temperature has to be what? What kind of inequality would I use here, Rex? The temperature for ice to be a solid needs to be or yeah, I think we could say less than or equal. It really should be less than, I guess. Less than 0, right, for it to be freezing. Okay, depending on what's in the water and that kind of stuff. If we don't have pure water, it's not going to freeze right at 0. It may freeze a little bit above or a little bit below 0. But we'll just say that T has to be less than 0. Now we need to graph this thing. All right? Now we'll see. When we're graphing, we have one variable, so we're going to have one number line. What number should I make sure that is on this number line? Alex B? 0. This is the critical number. I need to make sure that 0 is on there, right? Now, Julian, I'm going to put a circle around 0 because T can be lots of numbers, right? It could be -1. It could be -6,000. Okay, maybe not -6,000. Okay, that's more than absolute 0. Okay, so not that. Maybe like -40. It could be a lot of stuff, right? Can it be 0? Does it say T can be less than or equal to 0? It doesn't say that, does it? It says that T has to be less than 0. So I'm going to leave the circle around the 0 open because it doesn't include 0. But I'm going to shade everything on this side of 0. These are all the numbers it can be. I am shading the things that T can equal. T can equal -1. It can equal -2. It cannot equal 1. It cannot equal 2. And it can't equal 0. That's why that little circle is open, because it cannot equal it. What if it could equal it? What would I do to that little circle, Taggart? I would color it in. I'd make it a solid dot. All right? Great job, guys. We're going to do a lot of practicing with graphing. I'll see you at the next example.